last thing we're going to look at this week is 3.2, part 2. So still talking about linear functions. Okay, so on your guided notes, the first thing that you have a blank for is it says a blank is an ordered pair that makes an equation true. That's called a solution. Okay, so a solution of a linear equation with two variables is an ordered pair or a coordinate that makes it true. Let me give you guys an example. Okay, I'm going to do a little different one that I can do in my head easier. Okay, so first question, is that a linear equation? X plus y equals 5. Yeah, it could be made to look like y equals mx plus b just by subtracting the x to the other side. All right. I want to see if somebody could give me a coordinate that you could plug the x in here, you could plug the y in here, and then when you add the two numbers together that you give me, it equals 5. Anyone think they could give me a coordinate? Yeah. 2, 3. Yep. So 2, 3 is a solution to that equation. It's not the only solution. Can someone give me a different coordinate that you could fill in the x, fill in the y, and then when they add up, they give you 5?
4 and 1.
Yeah, 4 and 1. That's another solution to that linear equation. Right? How many solutions are there? How many numbers can you add together and get 5?
Maybe.
How many?
Maybe infinitely.
Yeah, there's infinitely many. I mean, you could do 100 and negative 95. Right? 100 and negative 95 gives you 5. So there's infinitely many. But that's what a solution is. It's just a coordinate that you can plug in, and it comes out true. Okay, so is this part on your guided notes? The graph of a linear equation is the set of all the points that make it true. Nope, I don't think you guys have that part. So the idea now is if you start listing all the different coordinates that make this true, there's infinitely many, so you can't list them all. But if you list a bunch of them, and then you start graphing them, you'll get a picture of that equation. Now, what did we say the shape of this was if you draw it? It's a line. And how many points do you think you need to make a line? Like if you wanted to draw this, could you do it with just 1 point?
No.
No, because if I want to draw a line with 1 point, there's a lot of lines that go through 1 point. So how many points do you think I would need to draw this line at a minimum?
2.
Yeah, as long as you have 2. If you have 2 points, there's only one line that you can draw that would go right through those 2 points. We have 2 points that we came up with right there. So if you head graph and you draw those 2 points and put a line through them with a ruler, that's exactly what this would look like. You only need 2 points. Any 2 points would work. Right? So if somebody else did one like this, that's another point you could plug in. How about this one? Is that one different from that one?
Yes.
Yeah, those are different coordinates. Do they both work if you plug them in? All right, let's try. So let's try this one. The x is 0 and y is 5. What's 0 plus 5? 5. So that one works. Now this one, x is 5, y is 0. What's 5 plus 0? 5. So do they both work? Yeah, they both work. And they are different. Okay, switching the x and the y, that's a different coordinate. One of them is 5 right, the other one is 5 up. Now, in that problem, you could plug in anything you want for x. You can even start to get fancy. You could do like 1.5 and then 3.5. If you add 1.5 to 3.5, you get 5, right? So you could start using decimals. You could start using fractions. You could use negative numbers. There's a ton of things that add up to give you 5. But sometimes you can't use any number you want for x and y. Like when we're doing a word problem. Let's say x represented the number of tickets you buy to a concert. Could you buy 1.2 tickets to go to a concert? No, that doesn't make sense. So sometimes you can't let x be anything. Okay, another example where it couldn't be any number is maybe x represents the number of nights you pay for a hotel. Well, you can't pay for 1.4 nights. You can pay for 1 night at the hotel, you can pay for 2 nights, but you can't pay for like 1.4 or 1.6 nights. They don't do that. So sometimes the domain is only certain numbers. When that happens, that's called discrete. Okay, so something that is discrete means that the domain is only certain numbers. An example of something that's not discrete would be like the temperature outside. Could the temperature be 50 degrees? Yep. Could it be 50.5 degrees? Yep. Could it be 50.36? Sure. Temperature can be any number, right? It can be any number. It doesn't have to only be 50 or 51. The temperature could be in between. So temperature, that's an example of something that's not discrete. How about your age? Could you be 15?
Yes.
Could you be 16?
Yes.
Could you be 15 and a half?
Yes.
Yeah. Could you be 15 and a quarter?
Yes.
Yeah, you could be any number between 15 and 16, right? You could be 15.24 years old, you know, whatever you want to be. Because time is continuous. That's the difference. Okay, so now let's do a graph. And it says we're going to graph all integers from 1 to 5 on a number line. Okay, so you guys have a number line. Let's just number it. Okay, when we talk about integers, we don't include fractions or decimals. Okay, no fractions, no decimals. So if you're graphing all the numbers from 1 to 5, just the integers, the first one is 1. What's the next number after 1 if you can't use fractions or decimals? Just integers. What is it?
2.
2. So we'll graph 2. What's the next thing you would graph? What's the next integer after 2?
3.
Okay, and the next integer?
4.
And the next one?
5.
5. So a lot of times when you graph something that's discrete, it looks like individual dots. So you can think they both start with the letter D. Discrete. When you graph it, it looks like dots. Discrete dots. Any question on that? Okay, so a lot of different things that are discrete. How about like the price of something at a store? Could the price be any single number that exists in math?
Yes.
So you could have a price that's like $1.267.
Yes.
No.
Yes.
Wait, no.
No, because price stops. Price can only go to the second decimal place. So you'd never go to the store and see something that costs $3.568. I mean, that's a number in math, but it's not a number you'd ever see for a price. So you could see a price that's $3.15, or it could be $3.16. But there's no price that's between $3.15 and $3.16. There's no such thing as $3.15 and a half. Okay. So price is an example of something that is discrete. Okay. You can't have every single value. Any question on what that means, discrete? Now the opposite of discrete is continuous. Continuous means, well, you got it mostly written, you just have to fill it in. It says we can also have what is called a continuous domain, which and then you want to fill in that next line. Continuous means it contains all numbers. Every single number. Okay? Fractions, decimals, contains all of them. So a good example of that one was temperature. Okay? Like if you measure the temperature outside, the temperature could be any number. Could be 50.264415 degrees. It could be. Whether you can measure it that accurately, well, that's another question. If you have a thermometer that's that accurate, but it could be. Okay, age. That's another example of something that's continuous. How about if I have like a candy bar and I want to know how much I could eat of the candy bar? Could I eat like half of it? That's a fraction. Yeah, I could eat half. Could I eat like a third of it? Yeah. Could I eat like 0.2? That's like a fifth of it. Yeah, I could eat any amount of it that I want. Right? I could just shave off a really, really tiny amount. So when you're eating a candy bar, that would be considered continuous because you could eat any amount that you want. It's not like you could only eat all of it or half of it. You could eat in between all and half. You could eat a quarter of it. You could eat any amount you want, and that's fine. All right, so now what I want to do is graph all the numbers from 1 to 5 again, but I want to do it continuously. Okay, so we're going to graph all the numbers from 1 to 5 going continuous. So the first one is 1. If it's continuous, could you have 1.01? Yep. Could you have 1.0002? Yep. Could you have 1.0003? Yep. Basically, there's so many dots that they look like they're connected. So when you graph continuously, it looks like a solid line. And it looks like a solid line because there's billions and billions and billions of dots. There's actually infinitely many dots.
Or uncountable infinity.
Yeah, that's uncountable. You can't count the number of numbers between 1 and 5 because there's so many decimals.
Or 1 and 2.
Yeah. Okay, so that's continuous. Any question on that? All right, so we'll talk more about that. We're going to do some examples where I asked you, like, is the domain discrete or continuous? And we'll kind of work through them together. All right. So the next thing we're going to look at, and we're going to combine it with what we just learned in a minute, is how do you draw a picture of a function? So like if I give you this formula, how do you make a picture of it? That's what I'm going to show you how to do. So the first thing you're going to do is you're going to set up a table that looks just like this. You guys don't have those filled in. You've got 4 empty boxes, but you want to fill those in. So to draw a picture of something, you're going to set up a table with four columns. The first column is going to represent an x value. The second column is going to be a formula. What's the formula? Well, they'll give you the formula, like y equals 15.95x, or m equals 50 minus 9d. Okay, they'll give you a formula to put in the second box. Okay, so that's a formula. A lot of times it'll be y equals, but it could be a different letter. Like if you were dealing with a problem that was about money, they might use the letter M for money. Okay. In this column, the third column, that's going to be when you do the formula out. So we're going to write down a calculation here. In the third column, you'll put the answer. And then in the fourth column, it's really the number you had here comma, the number you had here. So there's no real calculation for the fourth column. It's just taking the number in column 1. So it's column 1, comma, column 3. That's that column. Just take the number in column 1, comma, the number in column 3. Okay, now for the first column, for the x's, you get to pick what you want to use for the x's. Just like when we were making up points for this. I didn't tell anybody to pick 2, 3. Somebody just said 2, 3. And again, I didn't tell somebody to pick 4. They just said 4. You can pick any numbers that you want for the x's. In general, we try to pick numbers that are small and easy to work with. Okay. Try to keep the x values pretty simple. Right? And we'll go through an example. And then the last step, okay, step 3, is to decide, is it discrete or continuous? Okay. What that's going to change is, if it's discrete, your final answer is going to look like that. It's just going to be dots. If it's continuous, then your final answer is going to be connecting the dots. So, right, so think continuous, connect. CC, continuous, connect. Discrete, dots. And that's mostly what we're going to do today. We're just going to graph. We're going to try doing like 3 different graphs. And the graph paper, you already have it printed on your guided notes. So that's all you need. Okay, does everyone have the 3 steps? Okay, so example 1. It says the linear function y equals 15.95x represents the cost in dollars if you buy X tickets. Okay, so that's a formula to calculate how much it would cost for you to go to the museum. So like if you bought 4 tickets, you'd plug in a 4 for X, multiply it by 15.95, and that will tell you the cost for the tickets. Now, it says each customer can buy a maximum of 4 tickets. So in this case, I said you could pick any X value you want, but they are limiting us here. You couldn't let X be 5 because you can only buy 4 tickets. So 4 is the highest. So it says find the domain of the function. All right, let's start with that. So when we write the domain, there's 2 ways you write the domain. We've talked about both. If it's discrete, you're going to have a list of numbers separated with commas. If it's continuous, you're going to have the letter in the middle, the small number on the left, the big number on the right, and both inequality signs point to the smaller number, right? They both point to the left. So that's how it's going to look if it's continuous. Let's think about this. X is the tickets that you can buy. So think about, can you buy any amount of tickets that you want, or can you only pick certain numbers for the amount of tickets you buy? Yeah. Can anybody tell me why? Why can you only have certain numbers for tickets? Yeah?
Because there's a maximum of 4 tickets.
Okay, it's a maximum of 4. Anything else in terms of buying tickets? why can't you pick any number you want for the amount of tickets? Any number in math up to 4. Yeah?
Because it needs to be a whole number.
Right, it has to be a whole number. You can't buy 4.2 tickets. You can buy 4 tickets, or you can buy 3 tickets. There's nothing in between 3 and 4. All right, so let's write down the domain. What's one amount of tickets that we could choose to buy? Yeah, you could choose to buy 0. So technically 0, that's in the domain. What's another amount of tickets that we could choose? 1. Another amount?
2.
Okay, and then 3.
4.
Any other amounts?
No.
No. Those are the only numbers that you could say if you go online and you put in how many tickets you're going to buy. Well, if you're going to buy 0, you wouldn't be buying anything. But these are the only numbers that would make sense. Okay, 0, 1, 2, 3, 4. You can't buy 5 because it says you have to stop at 4, and there's nothing in between. Okay, so that's the domain. And now you can only buy certain numbers. So is that discrete or is that continuous? That's discrete. Yep. And Eli, what makes that discrete?
Because it's you can't buy like half a ticket.
Yeah, you can't buy anything between 2 and 3 tickets. Okay, so it's just certain numbers. That's discrete. And if we were to graph that, would it look like dots between 0 and 4, or would it look like a connected line?
Dots between.
Yeah, it would look like dots. Discrete is always dots. Yep. Okay, now let's see, do they give us, okay, now they want us to graph using the domain. All right, so now we're going to make that table. Okay, so let's put, I think what I'll do is I'm going to just move this down a little bit. Just move that down there. All right, so the first column is the x. So let's put that down. Second column, that's the formula. So we're going to put y equals 1595x. The third column is the y. And the fourth column, which isn't really anything new, it's just the column 1, comma, column 3. Okay, so let's write down all the x's. Madeline, what are the x's that I can use in my table?
0, 1, 2, 3, and 4.
Yeah. So we got 0, 1, 2, 3, and 4. Okay, and what we'll do, I'm just going to try to make it look kind of like a table. Good enough. And now we'll do each one. Okay, so let's start with 0. Take 0 and fill it in for the x. So y equals 1595 times 0. Okay, the next one, 1595. And what am I going to fill in for x this time? 1. And then to calculate this one, it's 1595 times 2. And 1595 times 3. And this last y value is 1595 times 4. Now we're going to do all those out, and we're going to put the answer in the third column. All right. Let's see if we can do the first two. What's 1595 times 0 tickets?
0.
Yeah, so there would be no cost if you buy 0 tickets. How about if you buy 1 ticket? What's the cost?
1595.
Okay. How do I use my calculator to get the cost for 2 tickets? What would I type in? Yeah?
15.95 times 2.
Yeah, 1595 times 2. So that's, how would I write that as a price?
$31.90.
That's $31.90. Yep. Remember, with money, we always want to go 2 decimal places. So $31.90. And then $15.95 times 3. Let's see. That gives me $47.85. And then $15.95 times 4. So $15.95 times 4 tickets. That's $63.80. Okay, so now we're just going to take what we have in the X column and what we have in the Y column and put them together to make a coordinate. Okay, so what's going to be my coordinate for the first row? Yeah. 0, 0. Yep. So 0, 0. Evelyn, what's going to be my coordinate for the second row?
1, then 15.95.
Yep. So 1, 15.95. Okay. My coordinate for the next row, about 10.
So is 2.
Yep.
And 31.90.
So 31.90. My coordinate for the third row, Lily? Or well, actually, we're on the fourth row.
So 3. For 47.85.
Yeah, so $47.85. And my last row, how about Eric?
It would be 4 and 64.
4 and
63.8.
yep, 63.8. Okay, so now we're going to graph that the best we can. Obviously, we got some decimals here, so like 47.85. Yeah, we'll just graph it like a little under 50. Right, so we'll do the best we can. Now, my graph paper only goes up to 10. So if I count by ones, is that going to be high enough for my y values? No. So what I should probably do is, I would say count by tens. So like, let's make each line 10. So 0. And do we need to go above 60? Yeah, we do. 63.80. Okay, so we'll go by tens there. How about the x's? Could I go by ones for those?
Yes.
Could I go by ones for my x's? Yeah, those aren't that big. So we could just have this be, let me zoom out a little bit so you can see the whole thing. This would be 0, 1, 2, 3, 4. Okay, so the first point that we have to graph is 0, 0. All right. The next point is 1, and then it's about 16. Okay, so just graph it the best you can. I'd say like right about there, in between 10 and 20. The next one is 2, and then a little bit above 30. So we'll go 2, a little bit above 30. 3, a little bit below 50. Right, we're just estimating the best we can. So 3, oh wait a minute, did I do that one right? 2, oh, a little bit above 30. Oh, I put it in the wrong spot. Sorry. 2, a little bit above 30. 3, a little below 50. So 50 is right there. A little bit below. And then 4, a little above 60. Almost halfway between 60 and 70. So 4, about right there. Oh, no, it's hard for me to see it. So 4, it's up 1 from there. So 4, about right there. Okay, do those points look like they're in a straight line?
Yeah.
Mm-hmm.
Yeah. Yeah.
Almost.
Yeah, that looks pretty good. Again, we just estimated the best we could. Now, should I connect the dots or just leave it as dots? Yeah, just leave it as dots because it's discrete. So that's how you do it. If it was continuous, then I would have connected this. Yeah, just say no. Okay, any questions on that? All right, so we got two more pretty similar to that. I'm going to let you guys try example 2. So I think you've already got it on your guided notes. Just make sure it's the same thing. It says the linear function m equals 50 minus 9d represents the amount of dollars of money you have after you buy D DVDs. So find the domain of the function. Now, you're basically starting with $50. Do you have an unlimited amount of money? No. Then the amount of DVDs you can buy can only go so high. Like, you can't afford 100 DVDs. Right? You don't have enough money for that. So when you get to the point where you run out of money, that's where you need to stop spending. So you'll make your table. Start with D equals 0 when you're graphing it. And then keep going up until you run out of money. Right? If it would cost you more than $50 to buy the amount of DVDs you want to buy, you can't do it because you only have 50. All right. So that's how you'll do your graph. And then the domain, you'll write that down just like we did the last one. So what I can do is I can leave that up so you can see how to do it. What's that?
Is the domain a 9?
Well, the domain is going to be the numbers that you plug in for X. So it'll be a list separated with commas. So the domain is the number of DVDs that you can buy. So this is like your Y. And the D is like your X. They're just using a different letter because I think D stands for DVD and I think M stands for money. Yeah. But you're going to do it exactly like you did that one. Okay, so this one says that you're buying a certain amount of DVDs. First of all, is that discrete or is that continuous? That's discrete. You can't buy like 2.3 DVDs. You can buy 2 or you can buy 3. Okay, so it's discrete. And the domain, this is what is going to be the numbers in the first column on the table. So what's the smallest amount of DVDs you could choose to buy?
0.
Yeah, you could buy 0. Do you have enough? And how many can you afford up to? You can afford to buy up to how many?
50.
You can buy 50 DVDs?
5.
Yeah, you can buy up to 5. Okay, so you can afford to buy up to 5 DVDs. So that means you could buy 1, you could buy 2, 3, 4, or you could buy 5. If you try to buy 6, you're going to end up with a negative amount of money because you don't have enough money. Yeah.
Wait, where does it say that you can only buy 5 DVDs?
Well, it doesn't say you can only buy 5, but it says this is the amount of money that you would have left. So can your amount of money at a store go negative and they'll still let you buy things? No. So it just doesn't, we have to just kind of like think about that one a little bit and say, yeah, you can't have negative money at a store. So 5 is the max. All right, so there's the domain and the discrete. Now let's make a table. All right, so what I'm going to do, just move this down again. Okay, so the first column is X. Next column is the formula. M equals 50 minus 9D. 9D. The next column is, it's normally Y, but in this case, they use the letter M. So we're going to use M. And then the last column, that's going to be our coordinate, which is normally X comma Y. But in this case, it's going to be D, comma, M. It's always column, so actually I should make that a D as well. That's a D. The last column is always column 1, comma, column 3. All right, so let's make some rows in our table. Okay, I think we had 6, so I need another one there and another one there. All right, what's the first value that I could pick for the number of DVDs? The first one was how?
0.
Was 0. And we went up to 1, 2, 3, 4, and 5. So now in the second column, you're going to write down your formula. And the amount of money you'd have left if you buy one DVD is 50 minus 9 times 1. So what they're assuming in this problem
What
is
about the 0?
9 times 0, yeah, there you go. They're assuming each DVD costs $9. Okay. Then 50 minus 9 times 1, 50, 9 times 2, 50, 9 times 3. And then in the next column, we're going to put down the answers to all of these. 50 minus 9 times 5. And you can't do 9 times 6 because that would cost you $54 and you only have 50. So you'd go negative. All right. So now we just have to write down the money. If you start with $50 and you don't buy any DVDs, how much money would you have left?
50.
You'd have 50. Okay. If you buy one DVD, how much would you have left? $41. If you buy 2, what's 50 minus 18?
32.
32. Okay. What if you buy 3? How much would you have left? 23. And if you buy 4, you would have 14. And what if you buy 5 DVDs?
5.
You'd have 5 left. Okay. So now let's write down the coordinates that we're going to graph. Okay. Sam, what's the first coordinate we're going to graph?
The chart.
Yeah. What are we going to put right here?
0, 50.
Yep, 0, 50. Eli, what's the next one?
141.
141. Yep. How about Eric, what's the next one after that?
232.
So 232. So we got some big numbers for y. We're going to have to make the axis probably go by 5s. Okay, the next coordinate, Evelyn?
323.
323. Lily, the fourth one?
Yes. 414.
So 414. And the fifth one, Zach?
5 and 5.
Yeah, it's 5, 5, and 5. What's that?
5, 5, 5, 5.
5, 5. Yeah, all 5s.
Nice.
All right, so let's graph. So what I would do first is let's label on the grid what we're going to go by. Yeah.
In the last parentheses thing, why is it 5 and 49? Number 5 in the parentheses.
Because that number in the parentheses goes up by 1 each time. So it was a 0, 1, 2, 3, 4, and then 5.
Okay.
So it's just that's just the number of DVDs. If you multiplied it together, like 9 times 4, you could put 36 there, or you could put 45 there. But we just did that step when we did the M column. Okay, remember, this is like that's like your X, and that's like your Y. Okay, they just use different letters this time. Okay, what should I go by on the Y's? Because I got to get all the way to 50. Yeah, if you go by 5s, we'll have exactly enough because there's 10 blocks. So we got 5, 10, 15, 20, 25, 30, 35, 45, 40, 45, 50. And for the x's, I would go by ones. Okay, just so I don't have to keep scrolling up and down, can someone remind me, what was the first coordinate?
0,
Okay, 0, 50. And the next one?
141,
141. So I'm just going to estimate right about there.
232,
232, right about there.
323,
So 323, I'd say right about there. Okay. And now I can see the other ones. 414, right about there. And 5, 5. 5, 5. Yeah, that's pretty good. Should we connect them or leave them as dots? Yeah, leave them as dots. All right. Any question on that one? So we've done two that are discrete. So probably have an idea what might happen on this last one. And let's do this one together. So it says a cereal bar contains 130 calories, and the number of calories consumed is a function of how many bars that you eat. Okay. So the first thing is, does this represent a linear function? Well, to figure that out, we should make a table and see if we add the same thing each time. All right. So let's start with x. So this is going to be the amount of bars that you eat. And how many calories do you get from each bar that you eat? 130. So what if you ate 2 bars?
260.
260. So what did you do to 130 to get 260? Doubled it. So the formula is going to be y equals 130 calories times how many bars you eat. If you eat 1 bar, you get 130 calories. 2 bars, 260. 3 bars, 390, and so on. So then we'll put our y, and then we'll do our coordinate. Okay. What if you eat 0 bars? How many calories would you get from eating 0 bars? 0. 1 bar. How many calories would you get from eating 1 bar if you eat the whole thing? 130. How many calories from 2 bars? Okay. And let's just say you only have 3 bars to eat. So we'll stop at 3. But if you had 20 bars, then you should eat 20 bars. So 3 bars. How many calories do you get from 3 bars?
390.
390. Okay, so let's make some coordinates. What's your first coordinate?
0,
0, 0. A lot of times 0, 0 comes up a lot. What about your second coordinate?
130.
1, 130. Your next coordinate?
260.
2 bars, 260 calories. And your third coordinate?
330. 330.
9.
There we go.
So now it asks us, does this represent a linear function? Okay. For a linear function, you're checking to see if you add the same thing each time. How do you get from 0 to 1? And then 1 to 2? And 2 to 3? Okay, so you keep adding 1. Now, how do you get from 0 to 130?
Add 130 3 times.
And then if you add 130, does it get you here?
Yes.
And if you add it again, does it get you there?
Yes.
Okay, so is this linear?
Yes.
Yes, it is. So yes, it's linear. Okay, find the domain. So let's find the domain, and I'm just going to assume you only have 3 bars. We gotta stop somewhere. Okay. So now think about the bars. If I put 3 bars in front of you, could you choose to just eat one of them? Could you choose to eat half of one? Could you eat a quarter of one? So what do you think about the domain of this problem? Discrete or continuous? This is continuous. You could choose to eat any amount of the bar that you want. Any amount. So now, when we describe the domain, what letter do we always use for domain? Is that the X or is that the Y?
X.
That's the X. What's the smallest amount of bars that you could eat?
0.
0. What's the biggest amount of bars you could eat?
3.
3. And which way do the inequality symbols always point? To the smaller number. So the domain here is any amount of bars between 0 and 3. 1.5 bars, 2.5 bars, 2 1/4 bars, 2 3/4, anything you want. I'm going to hold off on graphing it. The graph is pretty similar to what we already did, but this one was continuous instead of discrete. So when you graph it, would it look like dots or a solid line? This would be a solid line to connect the dots. Yep. So just reminder that we have our reference sheet on Google Classroom. You do not Google Classroom, Schoology. Sorry. You can print it if you want, and if you do it, it's extra credit. Let me write it here. So the homework is 3.2 part 2. The review sheet is extra credit. And I will be after school today if anybody needs to check in with me for extra.